Good morning, Year 10 Prep Specialist class. How are you going? Hope you're doing fine. Hope you also had a restful and good holiday. Welcome back to term 2. So today we're going to continue our algebra topic. We're going to look at the division algorithm, continuing on with our rules booklet. So on page 6, we're going to look at the division algorithm. So we're going to first throw back to primary school or even year 7 when we looked at long division of numbers. So for example, suppose you want to divide 227 by 3 and you want to work out the remainder when you divide that. So we would do a long division. So 227, the bigger number goes inside, and then divided by 3, the 3 goes outside. So you go 3 into 2 cannot do, so 3 into 22, well, it's 7. And then 7 lots of 3 gives me 21, so I subtract to find the remainder. 22 take away 21 is 1, so it's remainder of 1. I then carry the 7 down, so I have a 17, and you think, well, 3 into 17 is what? Well, the biggest number could be is 3 times 5 is 15, and you take away to find the remainder. And you stop there because 2, the remainder, is smaller than 3. So back up here we can write that 227 divided by 3 equals 75 wholes, because on the top we've got a quotient of 75, and then we have a remainder 2. 2's left over. So in terms of terminology, 227 is the dividend. It goes inside our long division symbol. 3 is our divisor. It goes outside. The whole answer is 75. It's the quotient, and whatever's remaining, the 2, that's called the remainder. So that's how it works with numbers. We're going to extend this to algebra. So consider example 11. It says use the division algorithm, so use long division to divide 2x cubed plus 7x squared plus x minus 10 by x plus 2, and hence completely factorize that cubic 2x cubed plus 7x squared plus x minus 10. So there's 2 parts to it. So first we need to long divide, and then we need to fully factorize it. So our dividend is this 2x cubed chunk, while our divisor is our x plus 2. Again, you'll notice that our dividend is bigger than our divisor, and in algebra's case, bigger means that the power is higher, or the coefficients and the powers together are higher in the dividend rather than the divisor. So let's write this in long division notation. So let me draw my long divisions. There we go. The dividend goes inside, so 2x cubed plus 7x squared plus x minus 10. You'll see that we have written the dividend in descending order in terms of the powers of x. So it's cubed, then squared, then x, then no x. So make sure it has to be arranged in descending order. We also need to put in descending order the divisor, in this case x plus 2. So the highest power of x and all the way down to 2. Alright, so it's long division time. So you're thinking, first up, look at the highest power for both the dividend and the divisor. So in the divisor, the highest power is x. In the dividend, the highest power with coefficient is 2x cubed. So the first thing you're thinking is, x times what gives me 2x cubed? Well, x times 2x squared gives me 2x cubed, because I need x times x squared to give me x cubed, and I need the coefficient of 2 to get me to 2x cubed. So I need a 2x squared, so that when I multiply 2x squared by x, I end up with 2x cubed, the highest power of that dividend. So you'll also notice that I've stacked the x squared on top of the x squared. That's just for aesthetic reasons. It just looks prettier when it's stacked and aligned. It's kind of like how we align the tens and ones column when we long divide in numbers. Okay, so once we've got the start of the quotient, what do? So we multiply through this first term with every term inside my divisor. Alright, so 2x squared times x gives me 2x cubed. 2x squared times 2, because that's the next term of your divisor, gives us a positive 4x squared. And that's it. So similar to what we did back up here in the long division with numbers, we took away the 21 so we can see what remainder we get. Again, here we need to take away to see what remainder we get to. So we're going to take away, and very, very importantly, make sure you put brackets around subtraction, so you're taking away the whole thing. Now, what's left over when you take away? Well, 2x cubed minus 2x cubed gives me 0, which is what I want, because I want to narrow down the powers. 7x squared minus 4x squared gives me a 3x squared. And then I carry the remainders down. So the remaining parts is x minus 10. I'm going to carry those down. So plus x minus 10. So other things to notice is that because this is an x cubed and this is an x, this is 1 power lower, because x and x cubed differ by an x squared. We're going to keep dividing because this x squared is still bigger in power than my divisor. So we're thinking, okay, x times what gives me 3x squared, because that's the temporary remainder right now. Well, I need to multiply by 3x to give me 3x squared. So again, we need to multiply 3x through, because that's our second term of our quotient. Oh, sorry, yes, our quotient. Through with every single term in our divisor. So let's do that. So 3x times x gives me a 3x squared. 3x times 2 gives me a positive 6x, and that's it. So again, we need to take away, but very important, make sure you put brackets around everything. So if you take it away, what do we get left with? Well, 3x squared minus 3x squared, they cancel. X minus 6x gives me a negative 5x. And then I have this minus 10, which I carry down. So minus 5x minus 10. So can we keep dividing? Yes, we can. Yes, the x's are the same powers in both the remainder, temporary remainder, and the divisor. And you can notice that the coefficient is different, so we can definitely divide through. So you're thinking, well, x times what gives me a negative 5x? Well, x times negative 5 gives me a negative 5x. So let's do it again. So minus 5 or negative 5 times every single term in our divisor gives us a minus 5x or negative 5x. Minus 5 times 2 gives me a minus 10. And then again, you subtract and then you put brackets around it. So minus 5 minus minus 5. So minus 5 plus 5 gives me a 0. Minus 10 minus minus 10. So negative 10 plus 10 gives me a 0. So I have a remainder of 0, and that's all nice. So what does this tell us? So that tells us that, therefore, 2x cubed plus 7x squared plus x minus 10 can be written as a product of whatever's on top in the quotient, which is 2x squared plus 3x minus 5 times the divisor, which is x plus 2. So that long division tells us we can write this x cubed as a product of two polynomials, an x squared polynomial and a single x polynomial. Now this is where we go to the second part of the question, hence completely factorize the cubic. So we can't factorize the single x anymore, but because this is a quadratic, a squared, we can use our previous learned techniques to factorize 2x squared plus 3x minus 5. So back up here, I'm going to say consider the quadratic 2x squared plus 3x minus 5, and we want to factorize it. So on the side, write down your A, B, C's if it helps you. So A is 2, B is 3, C is negative 5. We're going to do our plus B times AC little table on the side. B is 3, A times C is negative 10. So you're thinking of two numbers that multiply to be negative 10 but add to be 3. So the two magic numbers is positive 5 and negative 2. They multiply to be negative 10 and they add to be positive 3. So we can say that 2x squared can be written as, now because of this non-monic coefficient, remember we have to go bracket, 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 2x, because our coefficient of the x squared is 2, and we have to divide by that same 2 as well. And then inside the brackets we put in our two magic numbers, so plus 5 and minus 2. And then the next step is to factorize out anything in the top. 2 and 5 have nothing in common, that's alright. But 2 and 2 have something in common in the second bracket. So times 2x minus 1 all over 2. And that's what we want because the 2 and the 2 cancel. So we're left with 2x plus 5, x minus 1. So therefore, in conclusion, 2x cubed plus 7x squared plus x minus 10 can be written as, well, the quadratic factorizes as these two pairs of factors. So we write it as 2x plus 5, x minus 1, and don't forget that third factor there, x plus 2. So one other thing to note is that we started off with a cubic, so power of 3, so you can see that we have 3 lots of single x's, because x times x times x gives me x cubed. Now, on your exam, the easiest way to check your answers is, of course, to expand your brackets using FOIL, and check if you expand these products of linear factors, so just pure x factors, will you end up with this cubic polynomial that you started off with.